Oh crap. There's a Solana program thing, which published after the Golang stuff. So Golang stuff, I'm in Solpipe tool. Get rid of this. All right, so we'll have I consider to be kind of a big Golang library called Solpipe tool. Miguel, are you able to browse around the Solpipe thing? Solpipe tool folder?
Yeah.
All right, cool.
Folder. Yep.
Actually, let me. So the name earlier. So yeah, I mean, Solpipe tool basically executes the logic we discussed in the previous session. The README file I tried to add as to be as clear as possible. So we're going to have a README directory here. And there's stuff on testing. So testing's really difficult because you have to run a Solana validator. Miguel, are you on Windows, by the way?
I'm on the Mac when using Golang.
Okay, cool. How much RAM do you have?
I only have 8. That's why it's taking some time.
No, that's okay. Maybe unless you're running other stuff. The reason I ask is because everything here is run against a validator, and validator sometimes can gobble up some memory. And then since we're doing this kind of bandwidth auctioning, compared to other people developing for Solana, there are some tests that we need to run multiple validators, and not just one, and each one gobbles up a lot of RAM. So that might be an issue for you. But I got to work around. I think. Okay, let me get to it. So this is the code. We have all these directories. The best place to start is the state. So of course we have a docs directory for documentation. So I plan to put all the PowerPoint material in here. And then this doc directory will be definitive. Like this is the place you go for references. There's a, yep.
No.
Actually, let me delete. I don't want to delete stuff. Okay, there's a CBA directory and the CMD. CMD stands for command. CBA is a continuous bandwidth auction. So this folder just contains the entry point into the program. And I use this library called Kong. To parse command line arguments. And you can see how the logic for adding commands. So if I want to add a command, I just add one of these things, and then I can just fly around here. By the way, if you hit F12 in VS Code, you can like fly around to different places. Actually, let me do pipeline. So if I go to pipeline, there's subcommands. And so if I want to run the agent, I just type agent, pipeline agent, and then it'll run this. And then these variables will be read in from the command line. Okay. So that's the command part. We don't have to pay too much attention to that. There's a Golang test in here, though. This thing is kind of like a massive integration test where you run multiple validators in one shot, and it will go through the whole cycle, the whole bid cycle with multiple periods. So if you want to read how everything comes together, then this is the code that you need to look at. But it's woozy. And then there's a specific order that you have to like execute everything. So actually, let me tell you the order for this, because then you'll understand how this contract is supposed to run in the wild. Yeah, essentially, you run this test first, and then what will happen is there's these other test validator and test pipeline. Of course, later on, I'll add a bidder and a cranker and other tests. If you go to these tests, which is also in the CBA directory, you'll see this line, t.parallel.
Yep.
T-parallel means run everything in parallel. So Golang the Go will stop the test at this line until all the test functions have been read in with this parallel call. And then everything will be run simultaneously, which is important because, I mean, as you can see, we've got a pipeline agent, staker agent, validator agent, bidder agent. These things all run off of each other. So if you do an integrated test, I mean, they got to run simultaneously.
Yep.
Okay, cool. So integrated tests, this is where you dive in. Just F12 your way to glory. Okay, cool. Next part that you want to go to is state. So this part of the code is extremely important, and I think when we start, pretty soon we got to start thinking about the website again.
Mm-hmm.
And so I think the Solana dev environment for making the Solana programs have a mechanism to generate TypeScript libraries, which I think you've seen before. But yep.
I think I've seen it before. Forgot the name of it.
Yeah, I haven't touched it in a while. And to be honest, I don't think we're going to touch it because the state is just too complicated and I don't have time to produce state in TypeScript, because I'd have to duplicate. As you can see, there's 10 directories here, and each one is like full of code.
Yep.
And it's a lot of stuff to duplicate in TypeScript, and I'm not really sure what the benefit is. Just to be honest, the market for this is really small because it's only like people running websites who need to buy bandwidth, and the people selling bandwidth is not that many. So I think I'll just stick with Golang, Go code. But I mean, just to have a visual reference, we're gonna pull this. We're probably gonna have to pull the state out of here, either print it on a command line, which should be our default choice. But if somebody's like, well, I need to see it on a website, then we have to take the Go code and output it to a WebSocket. Yeah.
Yep.
Okay. If you ever need code from the chain, this is where you go. The main one is router. So router is, if we go to router's like the thing that fetches the state. So this is the entry point. What is this speaker shit? Oh, focus participants. If you don't mind, I'm going to use this focus participant button and just grab you wherever you are. Hi. So we want to focus on this line 37.
Yep.
Oh, by the way, this code is available on GitHub. I just pushed it yesterday, so I'll send you the link so you can take a look.
Okay.
It's not secret. It's not going to be secret code. It's secret-ish, as in it's like not publicly advertised, but it's open source. It's going to be open source code. The Solana program stuff is secret until I get people to use the Go code. Yeah, so don't worry. You have access to the code. It's public. But the create router. So what this does is it fetches all the state for every single thing that touches this program. How does it do that? If you F12 to the fetch program all, and you'll see a call on line 71. Get program accounts with ops. It basically says you give it the program for Solpipe, and it'll fetch all the Solana accounts. So all the state for every account will get returned.
Okay.
Yeah. And then just basically we just do a giant switch statement. There's the first 8 bytes of an account for this Solpipe program have a delimiter. You just read in 8 bytes, and then you're like, is this a controller? Is this a validator? Is this a blah, blah, blah? And then you just go through and read it in. And this is the I'm brain freezing. This is just an HTTP GET, a JSON RPC call. Yeah, but there's a WebSocket one somewhere. Where the hell says WebSocket? Yeah. So if you go to line 199. And by the way, do you know the shortcut to jump to lines in VS Code? Because I thought it was Command 11, but it's not.
Control G.
Ah, damn.
Go to line.
Yeah, I didn't know that. Thank you. Subscribe all. This is just a WebSocket connection. So like first we do the WebSocket connection and basically subscribe to all the events for this program, and we get the account updates, which by the way, if the account gets closed, it actually doesn't show up as an update here. So that's just back of your head. The account closes, you don't get an update for that. But yeah, WebSocket connection, get the account updates. My MO is first do the WebSocket connection first to get the event updates, and then to get the current state, you do the HTTP GET after you got the WebSocket subscription so that you don't miss any events. This is my MO. Okay, so let's go. All right, so and then these things and from the subdirectory, just going back to router, yeah, they interesting. I violated my own rule. What the? Let me move it here. There we go. Okay, actually, I have to. Interesting. I have to put a to do here. Add CTX cancel call here. All right. So once you've got that, I kind of have a subscription thing here. Basically, people subscribe to the state for the different agents and different accounts. And let me go to pipeline. And so this router object's got this WebSocket connection. So it basically feeds in the events to the different objects that we'll create. So let's say we get an update on, I'm on line 32. So I'm on line 32.
Mhm.
So of pipeline.go. So on pipeline, the router got an event update from the validator, and we get an ID of the public account, of the account, which is a pub key. We get the content of the account, which in this case is pipeline, which contains a bunch of information about the pipeline. Um, and we get a Boolean that says, is the account open or has it been closed? And then you can just follow the logic here. And, if the account is closed, then, go find, what is this? Let me be clear here. Go find if there's a pipeline that we have stored. If there is, then you're going to close the object because, the account has been closed on chain, and delete reference to it and leave. Let me be clear here. So, so like here, the account's still open. If we don't have a pipeline yet, then just create one. If it exists, then we don't have to do that. And then, yeah, I mean, just basically fill in the data. So pipeline, like I said before, well, pipeline object is special because it's got a pipeline account and a bid account and a periods account. But it's really just one state split into three accounts because the period and bid and period accounts are really big. So for technical reasons, they're split. But those three accounts are basically, it's just the pipeline state. So that's what this section is. It's just updating the bids and the periods. They're separate accounts, but it's the pipeline state. So so in the router, the MO is on pipeline. Another place is going to say on validator or on receipt, and then on the specific object, there's going to be an update function call where you update the state. There's an update payout. So, oh yeah. So sometimes on chain, parents point to children point to parents. Parents don't point to children, but off chain in the Go agents that we have, right? So payouts point to pipelines, right? Because they represent a period and the
Yep.
accounting, the money information for a period. So, just for convenience, we also just like put in the children into the parents in Go. So that when you're coding, you're like, well, what are the payout accounts that exist? What are the payouts that we're processing now for this pipeline? And then you could, and another function, you just get a list of the payouts, or you can get WebSocket, not WebSocket. I don't want to say WebSocket. You'll get an event update on the. If a new payout is created, you can get the payout object by subscribing to a data feed from this pipeline object. We'll see it later. Again, it's like, so we have this update function call. So basically the router's job is to take events on chain and shove it into the correct Go objects. And by objects, I'm talking about, well, an instance. I don't know. You might know a better name, but pipeline instance, or it's a struct with some methods on it, and it's got some channels and some state that's sacred. All right. Um, this is specific to Golang and not really to the Solpipe stuff, but yeah, you gotta clean up. Um, if you close the program, this pipeline stuff is running in a separate Go routine as per the Go tutorial, right? Where we have state to track and we use a internal Go routine that has control over the specific data content, right? So this you're going to see a lot of loop deletes. It's just basically cleanup. Okay. Let me go to pipeline. Crap. All right. So now we're out of the router package, and we're in here. If you look at this struct, which is passed by value, you can see all the data subscriptions that people can do.
Yeah.
Yeah. Pardon?
No, no.
Okay. So if I have a pipeline object, what, for example, like imagine you're operating the bidder agent as Alice, and Alice tomorrow from 9 to 12, she needs bandwidth. So she'll be listening to the router for pipelines or search for existing pipelines. Then as she gets the pipeline, she needs to know the price for the TPS. So the price for the TPS is basically not this one. Well, this one, because she kind of needs to know the fees and stuff. But actually, what she really wants is the period updates, and the bid updates. Bids is just like, how much are people bidding for it? So that's like the spend side, and then for the supply side, she has to look at this period ring and payouts. Oh shit, you don't get the payout update. All right. Anyways, so she listens for payouts and periods. So these are subscriptions. I think with these you can find the function calls. The function calls, generally speaking, is like on something. So here we go, like on validator or on relative stake. You would get access to this update. Here I have a real-time update of the on-chain stake. So with the stake, you can calculate the TPS. Actually, I should write that as a comment for you. Use the activated stake, not from Solpipe. Staking notes. Calculate real-time TPS. On validator, what do you get with this? Oh, you get a validator object. So if you have a pipeline object in your code and you need to find out the TPS and which validators are involved, you just listen for validators that are created. So, I mean, it's basically the pattern I've got. It's like on validator, on something, you get the update. There's an update section, but you don't really need to touch this stuff because this stuff is just for the router to talk to. Makes sense?
Yep, makes sense.
Yeah. So I mean, pretty much. I mean, I think for the most part, I'll be taking care of the state part, like writing code and stuff, and then the only part you'll be doing is calling these functions to get the data feeds. And I suspect if we have to do some sort of React component with a WebSocket feed to get updates, you'll be calling this function and translating it to a WebSocket
Ah, I see, I
data
see.
feed. Yeah, yeah. Not really sure how we're going to do that. But ultimately, I think we have to write a WebSocket server, and so people can just fetch the data. I'm just really lazy. I don't really want to do the work. Just a lot of just. I'm hoping that we don't have to do that. Well, at least we don't have to like hand roll the JSON stuff. That we can use the CBA. There's auto generated Go code that parses the on chain state, and I'm hoping that that has JSON like auto magically built in. Because if it does, then we don't have to do any translation. Okay. All right. So, yeah. So it's the same thing for all these functions. Well, network. Okay. So payout, pipeline, receipt, staker, validator. That's basically the agent stuff. And we don't really have to care about the controller. Slot is that's basically your clock. Ooh. So yes, one thing I have to warn is this was a big problem for me. If you have a WebSocket connection, this guy is on line 18. If you share that object across multiple Go routines, so kind of like multi-threads, you just share this connection.
Yeah.
If multiple Go routines subscribe to the same event, the event stops showing up.
It somewhat exceeds.
Pardon?
It exceeds someone like that.
I don't really know. I mean, the events just disappear. So in this case, this is a slot, which is basically your clock inside Solana. And by the way, this whole time I was talking about periods that start at 9 a.m. and end at 12 p.m., but it's actually slots.
Oh, okay. I see, I
Yeah.
see.
So, it's like slot 452,596, and then tomorrow you can guess the time that a slot will happen, but on chain, it's the clock is slot. Which means a lot of these state things require slot to track. Like the payout has a start and a finish, right? And which means you need to subscribe to the slot to figure out when to kill itself. Or if you're running an agent, you need to track when the period is finished, so you can start collecting your money. Anyways, so if you ever find yourself subscribing on WebSocket from multiple places, then you should think about using a special object, or in this case, I have a Go struct that lets me do subscriptions. Let me get rid of this sub2. I use this object called I use a subscription object, and generalized for subscribing to events. So if you ever need to do a subscription thing, you could just do this. I'll show you the pattern for it if you need it. I'll probably have to show you the pattern actually at some point. Like I got 10 minutes left. But yeah. So this is the state. So to change state, you need a script. So what's in the script object? Script object is not passed by value. It's passed by reference. So you can only have one script at a time wherever you are. You have to feed it in connection points to talk to a validator. And basically you use it to create transactions. That's it.
I see. I see.
So like you can see how the agents interact with the Solpipe program through this script. So if you ever see the script, it means something on chain is going to change. Like for example, controller, this creates the controller, which is the whole the controller is hard to explain. Actually, this whole time in the last hour and change, I never explained the controller, but I have to do that separately. It doesn't really mess with the logic. Let me go to a better one. Pipeline. So if you go to pipeline, it creates the pipeline account and the period account and the bid account.
Mhm.
And then like if you go here, you can see how it does that. This is the transaction. So a transaction in Solana is composed of multiple instructions, and instructions basically gives it's like, give me three things. Number one, give me the program that you're executing. Number two, give me all the accounts. So what accounts are you going to write to? What accounts are you going to read from? Just give me all the accounts. And number three is like, is there any argument you need to add? So in this case, I separated the accounts that they need to write to and read through and create and stuff. So that goes here. And the accounts are all identified by public-private key pairs. And then down here, I have this is just like fees and stuff that is set. Oh, by the way, all the fees that are proportional, I define as a fraction, 2 unsigned 64 bit integers. So you can see that. So yeah. All right, cool.
Yes, yes, yes.
Okay, so that's script. So state is reading the state, on-chain state. Script is changing on-chain state. Let's see, what's the time? All right. This section, you don't really have to touch it, but essentially what this section is Jesus, what is this section? By the word proxy, it's just basically the mechanics of the, we have Alice, right? She's a she bidded for the stuff. She needs to connect to the pipeline. And the pipeline needs to connect to all the validators. So this whole section is basically how they do that. There's a listener. It's got some cool stuff in it, but it's not really relevant to understand how everything works. It talks to Tor and stuff. It's got a connection, so it's connecting. I'll leave it at that. Yeah.
It's more of for the public usage.
Well, everything you're seeing is public. Well, will be public very soon. It needs to be public soon because Solana was about to make a change, and it's like do or die at the moment. It's always do or die, but it's like now it's really do or die because they did the software update for Quick and QoS. So like now I gotta do this. Maybe I'll go to McDonald's and just work 24/7. My wife will be pissed. Actually, no, she doesn't care. Maybe that's worse not to care than to be pissed. Yeah. By the way, if you have any questions, your questions are going to be very important because I need to write documentation so people understand what the fuck's going on, what's happening. I have to stop cussing. And I have a person, like I mentioned before, an apprentice person. She's learning too. So I'll use her. And the three of us, well, I think I'll try to get her to write the final documentation, but we need to like write down any questions you have. That's also part of this process because make sure the documentations, make sure somebody can actually use this stuff.
Yeah.
Okay. And probably next week, starting next week, I'm gonna reconnect with all the guys who are interested in this and see if they're still interested and try to get them to use it.
Oh, I see.
Yeah. So sales time very soon, which means I need a publicly presentable code base. um. Okay. What am I doing? Yeah, so this is proxy stuff. This is just basically so people can connect to each other. Cool thing is, one more point, for people to connect with each other, bidder to pipeline, pipeline to validator, the connection information is all on chain.
Ah, okay.
Not only that,
Mhm.
use a so the pipeline has a public key, right? Because that's how you
Yeah.
identify the account. Is basically essentially you use the public key from the pipeline account and from the validator accounts. That's all you need to connect to somebody. You don't need the IP address or port number or anything. You just need the public key that's on chain, and you just connect. And it's encrypted and authenticated, so it's you know that's what this code is for. All right. Last, the agents. The agents. Probably this is the section where a front end may be required. And by front end, I mean the dirtiest piece of garbage, just something barely functional that, well, I mean, functional, but just I'm not talking about the Solpipe website. I'm just talking about the user application. Yeah, I'm still not sure if I could do this in the terminal 100% or we're going to need a React front end. Anyways, let me describe the agents. So we have bidder, cranker, pipeline, staker, and validator. Staker and validator, these two are basically autopilot. And so is the cranker. The cranker is just the guy who the soul pipe, there's like logic, but to make the logic execute, somebody's gotta like execute a transaction that just says, hey, soul pipe, just like do stuff. So that's what the cranker does, and it's called cranking. Like
Ah,
you
okay. I see.
like you crank a jack in a box or a toy. You gotta wind up the spring so it does something. So that's what cranker is. Um, but it's not important to know like details about cranker because I mean the code's pretty simple. Pipeline and bidder, these are the two things really that requires some user interaction because the pipeline is selling the bandwidth. The pipeline person has to decide the periods, right? I mean, is it going to divide a 24-hour day into like 1 hour chunks? Or maybe tomorrow there's going to be, NFTs?
Yeah, penalty. Yeah.
There's going to be an NFT auction and the bidding and transaction volume is going to spike. So instead of doing a 1 hour period, I want to do a 5 minute period
Period.
and charge extra money. So maybe it's 5 minute period, 5 minute period, 20 minute period, 1 hour period. Right? There's some
Yeah.
variation of that. So that logic has to go into this pipeline guy. So whether that's user interaction or whether that's something else, don't know. So far, it's just like there's actually a gRPC client to talk to the pipeline agent. Okay. And bidder is actually the most complicated because the bidder needs the pricing in order to know how much to bid. And that's kind of like a real time thing where you have to like shoot money out the door. So this one's the most sensitive. It's basically the bidders. Let's see if I can show you some of the language. So like the bidder gets a list of all the pipelines, and once it gets a new pipeline, it gets Well, it needs a connection status because it's got to connect to the proxy to send transactions. Um, it needs a update on the relative stake size because that's the TPS calculation. Once you have the bidder has a real-time TPS calculation, and then once it's reading in the bid updates, you can calculate the price for TPS for a period, which I don't even know how to price that. Like, what's the language for that? If you have 5 TPS for 1 hour, what's the unit? 5 TPS times hour. I'm still figuring that out. I don't know the units yet, but essentially it's the duration times capacity. And capacity is something over time. You know what I'm talking about? Hello?
Kind of blurry.
Oh, okay. I got scared. I thought I was talking to myself. All right. Okay, so if basically priority wise, I think study the bidder, and I think this is where I think this is what's going to go on Solpipe, honestly. It's going to be the bidder minus money. It's just going to be like a read-only bidder.
I see.
Yeah, because then we could display the prices on the web page. That makes sense?
Yeah.
All right. So maybe we'll just analyze the bidder first and figure out how to put a web server in front of it. I also have to get you sample data. I think we have to do the next session over the weekend. You can give me a review of your Go client thing, and then after that, because I think the Go client is going to be integrated into the bidder agent, or the bidder agent's going to go into your Go client, right? Because it's a RPC proxy or something.
Yeah. It's an RPC.
Yeah. So this TX thing, so that's important to you. Okay, so over the weekend, I don't know how much time you have. Maybe just 1.5 hours, and we just go with that. 2 45-minute chunks.
Yeah, I think.
I don't want to mess up your weekend. Not yet. Soon, hopefully, yes. Hopefully, I get some sales traction. Okay. Yeah, let's just focus on the bidder thing. This is the key. This is totally the key here. Everything else is automated, so I don't really need to mess with it. It's just on me to, well, I mean, if you build up your Golang skills enough, then and Solana knowledge, then yeah, we can do this together. But for the start, bidder is the best place. That's the part where the humans need to see humans. Okay, cool. There's a 5-minute break, so started at 11. So we ended with like 30 seconds to go. So perfect timing. All right. Stop collaborative session. Let me finish this off by sending you the thing. There we go. And that's the Golang code. I need to figure out how to get you so you can do testing. But for now, between now, I mean, you don't have to do anything, but just maybe casually look at that bidder thing and just look at the code. Anyways. Okay, so that's it. Thanks.
Is it okay? Can you send me copy of the recordings?
Yeah, we'll do. I'll put it
Okay,
on
nice.
YouTube, and Not public YouTube, private YouTube.
Private.
Yeah,
Okay.
yeah.
Yep.
Okay, cool.
Thank
Thanks.
you.
Thanks. Have a good one.
Bye-bye.
Bye bye.